next one and the last one for today. On stage is Michael.
It's already running. Welcome to my talk, Signals Fine-Grained Reactivity in Angular. It's an amazing day so far, I would say, especially the last two already scratched the topic. Maybe it's a little bit unfortunate that I'm after Pavel. What should you do after the inventor, integrator of that whole thing in Angular? But I tried to do my best to give a quick insight on the dev preview of Signals. What does dev preview mean? That means that there might be some changes, some implementation details that will change, but we can already experiment, and this talk is about a little bit of understanding how it works under the hood and 1-2 experiments. The Angular team opened up this GitHub chat. You should definitely watch this space. Give comments, as Pavel said. If you work somewhere in that area, read all the comments, add your own comments, help to make those things better, the integration better, and the usage in third-party libraries. What was in that watch this space thing? I just want to highlight a couple of things that will be unlocked with this technology. They most probably unlocked fine-grained reactivity in the template, and they will help us to migrate to fully zoneless applications as stuff that I'm really excited about. And one very important thing, Signals are not just a library that you install and then it works in your framework. You have to integrate it, you have to understand how it plays with your own framework, and all this stuff is like the work from Alex and Pavel. It was digging into that stuff, understanding how you can get the best out of it. And here are some aspects of what they are proud of. They have a lazy evaluation of computations. They use quite some cool tricks with WeakMap to unsubscribe automatically. And they promised us an integration story with RxJS. And after they opened up that space, Twitter gone wild. Enea, one of our colleagues in company Push-based, was one of the first ones. He went online, forked that whole thing, and published a stack blitz so that people can experiment with it. We had Brandon, core team member of NGRX. He started an experiment on a router that is driven by Signals. Sender obviously also published a very nice sum up on different perspectives on that topic. Sarah did this amazing animation and explained all the details, how you use it in a wonderful, beautiful app. I mean, you definitely should click that one. We also had, and this is a good story, I was in India, it was 3 in the morning, I was fighting against sleep, and they started this 5-hour interview, and I survived. I didn't fall asleep, yes? So this was very nice one. Tim made something about forms, signal-driven forms, really cool experiment. And Julian, core team member of Rx Angular, also published an RFC how we could implement all that stuff and combine it with RxJS. That said, I will try to not point out more experiments, but try to dig in and see how this whole stuff is working under the hood. My name is Michael Hladky. The last name is pretty hard to pronounce and spell if you're not from Czech Republic, so let's stick with Michael. And let's dive into the real thing. A live demo, and when I watched or read a little bit of code, I was like impressed on, or not impressed, I was curious, how is this really working? Because it looked magical, and I will show you. And I will show you how we can check out what is magical about this. We have a counter example. I click that update button and it counts up, and I click reset, it sets it to 0. And this is like plain Angular, no RxJS, nothing, and I will convert that to signals. I will create a signal, and I will have an initial value. Maybe I should remove the typo that it works, but after that it should be okay. And now I have this signal, and the initial value is count, my green box, as Pavel said. Here I want to update my signal. It is not just assigning a value. We have a update function that takes the previous value, and we can implement it or increment that previous value. And setting a value directly is also a little bit different. You can call the set method. With this done, we have one signal that is like changing, and I want to use a computed here. It is a function that will react, that will execute whenever one of the internally used signals execute. And after that line, I was like, why? Why is this stuff working? This code here basically would update this variable whenever this function here is called, and I had no clue how this is connected under the hood, and it is also not really obvious if you read that lines of code. So let's try to see if the app is still working, and the app, if I click that buttons, still works. But not because of signals, just because zone.js is still active here. So let's try what would happen if I turn this application into a zoneless application. And I don't want to do that on the whole application because it will just destroy everything. I want to do it very fine-grained. I just detach those two buttons here from zone. So those two buttons that triggered change detection before are now like detached. And if I click any of those two buttons, nothing is happening. So why and how? Nobody runs change detection, and this computed here is also not really somehow connected to any rerunning. Tasks computed, as Pavel said, are lazy. So what we can do, and I want to implement here a constructor, what we can do is we can set up an effect to at least get a console log. Let's see how that goes. Digits, and now I console log that. Whoop. Okay, so this line of code here was also really magical for me. Why is the effect executing whenever I set a value on count that is then derived into these digits computed here? Why is this stuff executing? First, I will quickly show you that it really logs something. So I switch to my console, I click that button here again, and you see, beautiful, there is some log. So I have somehow subscribed to, where is it? Subscribed to this computed here, and this computed somehow subscribed to that count. But you don't see any code of that subscription. And in the next couple of slides, I hope that I can show you how this subscription thing here is done. And in the next steps, I will show you how you can really leverage that with a little bit more than just console logging the change, but really updating the template. I will start with signals, and a small teaser front off. Signals on their own are completely useless. They will not do anything. You can set a value, you can get a value, but that's it. But there are some underlying principles that I want to point out. So if you create a signal, you call that signal function with an initial value, you get out a signal of type number with an initial value 0. This value S, this value signal here, is explained as this number box with the purple border. And if you look, this purple border has another box hanging on it, and this box is called observer. This is a list of all other pieces of code that observe changes from this very signal. I created a signal, now I want to update a signal, and if I call set on a signal with a new value, internally under the hood, my signal will go to the list of observers that is completely empty now and update all of them, and at the moment it does nothing because the observable array is completely empty. Another line of code here, I get the value, and this is the key. The subscription is done by opening the box, by getting a value. So if I call a signal getter, like I get the value out of it, something really cool happens. This signal goes to a let's think about a variable that sits on the window object, so it's globally accessible by anybody, and it just pulls everything that is in there inside of its own observer list. At the moment, as you can see, this active context is empty. There is no active context, so nothing will get pulled in. But this code still executes. Okay, setting, getting a signal. What we learned is signals are not fully useless on their own. They have this notification mechanism, and those are the pieces, especially the get function, that really trigger the subscription. So there is no automatic subscription, but you do it by getting the value, by opening this box. Cool. We had that effect, and when I read the source code, for me it made the most sense that I first start with an effect and then go to a computed. So let's see if it also makes the same sense for you. What is a effect? If I update a signal's state or value, an effect that consumes that signal will get notified. But how? I create a signal, my number signal, and then I have this effect function, and my effect function takes a lambda. And within this lambda, I can put whatever code I want. I can put code that does not contain a signal, or I can put code that contains a signal, and guess what? I will use a signal here in that code. So I have this context here, and inside of this context, there will be logic in the future, but before this logic is executed, my effect basically goes to the, puts himself into the active context. The effect says, I am now executing, and this is me. I put myself into this global active context thing, accessible by everybody, and I just sit there, and that's it. And then in the next step, logic inside of the lambda function of the effect executes. Here, I just console log the number as I did before in my example. And as you remember, getting a value, opening the box, is the subscription mechanism. So when I open that box, when I get the value of my number signal, internally, if you remember the observable array here, the observer array, the signal goes now to this active context and pulls in whatever is there. And right now, we are in the context, in the execution context of this effect, and the effect itself sits as active context at the top, and the signal pulls this effect into its list of observers. And this is the subscription mechanism. From now on, and for the next run, this effect registered himself on the signal, and it will run the next time when I set a value. So now I set a value, and if you remember, if I set a value on the signal, the notification process kicks in. At the beginning, my observer arrays was empty, but now, as I executed this effect before, my signal knows that this one specific effect here, EF1, is one of its observers, and it will notify him, hey, I have something new for you, please open the box and see what's inside. So this is a whole limbo, and then notification of the observer starts, and after that thing, the whole stuff starts again, and all the processes that I described before will be identical, but the second run. The whole registration limbo starts again. So this is how a signal or an effect knows if something inside of him is changed. Is an effect male? I have no clue. In German it would be male, but in English maybe not. Sorry. So that was a very minimum example. You can obviously put multiple signals in an effect. Exactly the same thing. They would pull the effect in their observer list. They would know who to notify. You can also create two different effects from the same signal, would also be the same logic, same mechanism, and that's more or less it. The rest is just the composition out of those two things. And that was the effect part. So now, let's try to understand what the computed part of all that stuff is. The general idea of a computed. A computed first of all does nothing because a computed is lazy, but if somebody is interested in the computed's value, it can do the same thing as a signal. It could notify people that are interested in the computed's value, and I believe that was the yellow box in Pavel's talk. I'm not really sure. Next time I will put the colors there so that I remember. But let's see how that goes. I have my computed, I have the lambda function inside, and this lambda function consumes two different signals, a number signal, a Boole signal, and it just spits out the result, minus or plus one. Very not really exciting thing, but we can like see those two signals here, and we can understand now how the registration works. So my computed fires, and the same way as an effect put himself into the active context, also this computed will take a reference of himself into this globally accessible active context list, and then in this case here just console logs if somebody would execute it. The really cool part about computeds is they will not do anything if you don't use them. That's called laziness. Laziness is only doing something if you really need it and not before there's no like a promise that eagerly fires. You really need to call it, use it to execute that stuff. That's one of the beautiful things here, very similar to RxJS, which is also doing nothing if you don't subscribe to it. Also lazy. Okay, then I call my computed one here, and when I do that, this is the first time when all my internal signals, the number and the Boole value, go to the active context, to my window, and pull in the computed to their observers. And this is the subscription mechanism. And if I call it now, it is set up. And whenever I would change one of those values, the whole registration limbo, as before, would start again. That was just the basics. This is how the registration works. This was a little bit of internal things. At least for me, it helps a lot to walk over the slides because it takes away the magic, right? I can understand somehow what happens under the hood, and I'm not scared to use something that looks really magical. Maybe you like magic, I really don't. I want to know what is happening. So this done, let's jump to a little bit more advanced things. Let's try to implement or to connect signals with change detection. And I want to do that in two different levels. So the promise was signals will enable fine-grained reactivity in Angular. I want to demonstrate that with a pipe, and I want to demonstrate it with a structural directive. It is a sketchy thing because nothing is released, so you cannot expect that this is like production-ready code, but you will somehow get a clue on how we can use that. And all the concepts are basically derived from our already existing library, RxAngular, which was doing fine-grained reactivity with observables, with RxJS. Now we want to mix in also signals and have basically an interopt layer between RxJS and signals that is very easy to approach, feed, and consume. We have to start with the component tree. Angular and pretty much any other framework is a tree structure of components. This is how our mental model works. And in that component tree, we can do a couple of different things. And one of them that I want to show you now is how to render a component, or how to update a component's template whenever a signal or a computed would change. And to do that, I want to basically try out to have a signal that is notifying my component with an update with a next value, with a new value. I will call that push pipe, same as the RxAngular push pipe is named at the moment. This one here will also be able to consume signals, not only observables. And disclaimer front off, I'm not sure if this will ever land in Angular, but it will demonstrate on how you can connect it with change detection. Obviously, the real implementation will be way more smooth and nicer than this, but just to get a clue. And I will start by explaining how the async pipe works, and then I will try to explain what the push pipe would do when it consumes a signal. So here we have a movies observable, and this movies observable shoots the next value to my component, and when it receives it, the async pipe under the hood would call a method that is called mark4check. And this method walks the component tree from this very component up to the very top and marks every single component as dirty. That's it. No change detection, nothing, just dirty marking. After that process, zone.js kicks in this very example because a HTTP request entered, but anything else that is patched by zone would be registered by zone.js, and then zone kicks in and starts to call application ref tick, and then Angular goes top to bottom, re-rendering all the components on that dirty path until we end up on this very last one, and we exclude change detection on push for now to save a little bit of time. Okay, that was the async pipe. Now let's try to understand how it could work with the push pipe. With the push pipe, I will exchange the mark4check method with a method that is called detect changes. This method here will re-evaluate one specific component template, this very component template, and nothing else. There is no dirty marking, nothing. There is just updating, synchronizing the TypeScript or JavaScript state with my HTML. Also not really, I would not do that in production because it will destroy your complete app with making it very, very slow. So there is more magic behind it, but this is like what you should understand. And I will show you how I can refactor my application with a pipe. And to do that, I have already prepared a little bit of code. I will zoom in here so that you can see it better, and I will hide that error message. And what I do here is I have a couple of basic logics. My transform function basically takes a signal, some arguments. I check if this signal is different from the previous signal. I have my onDestroy logic, like all the default stuff. But here we have the implementation detail. Now inside of my pipe, I take that signal, then I call it, I get the value, I open the box, and I have to do that because this is the subscription mechanism. Without opening the box, no subscription ever is done, right? So I just uselessly create this variable here and pass it to my update view function that later on will call detect changes on my template. And if I do that, I can jump now in my template and I can say pipe push. And as you can see, I don't call the computed or the signal, I just pass it in as is. This is definitely different when Angular will land, but at the moment I cannot easily change the source code, so I just pass the signal without calling it, and inside of the push pipe it will get called. By doing this, it should work again. Let's delete that here. Yes, it should work again, and we already have one very big benefit. You see this number here that is updating? This is the components. This is the component, and it shows the number on how much this component's template got re-evaluated. And if you look here, this one, that's the cool part, that is the app component. And if I click the button, this number will not change. That means we already brought down re-evaluation from all the components in our app to this one single component, nothing else. So we already have some level of fine-grained reactivity, same as it would work with an observable and the push pipe in an existing RX Angular implementation. But we can go a little bit further. We can try to do more. That's what we want, right? More. We can write a directive, and structural directives have a really cool and interesting benefit. So let's look at this. We have a structural reactive in our component tree. I introduced two new things. There is not only a green square, not to mismatch with Pavel's green box. Then we have a dotted line. This is a view container reference, and a dashed line. This is an embedded view, and those are the building blocks of structural directives. If I look now on one component and I use my microscope and zoom in, I will see that this component holds a template binding, a value binding, and two structural directives, an ng for and an ng if. And if I would zoom in even more, I would see that all of those structural directives that have this view container reference holds one or multiple embedded views. And if you open up the source code of an embedded view, you will see that this embedded view has a method that is called detect changes. And this is really cool because it will not detect the changes on the whole template, but just on this one very single embedded view and nothing else. And this is real fine-grained reactivity on the binding level, at least on the binding level of a structural directive. And this would extremely boost our performance compared to the previous implementation. So how could this look like? Again, no clue what will land in Angular in the end, but this is how I made it work for now to demonstrate it. And I have similar logic. I check if the signal is different than from the previous signal, yada yada, unsubscribe thing. But then again, I have my effect. I open up the green box, I subscribe two changes from that signal, and then I pass the value to my update function. I update the embedded view, and then I call detect changes on my embedded view and not on the template and not on the full app, just on this one single binding. Let's see how I can use that. I will delete my pipe here. I'll copy that thing. And I go here, rxlet. I pass in the signal, and then I say store updates of this signal in a variable that is called digits, because I cannot use digits. Yeah, what should I do? You need to be creative. And now I'm really motivated and curious, and then we look at this number here and at this number here, and if I did my job right, nothing should update but this white number here in the black box, and I click the button now, and boom. No update nowhere. This is fine-grained reactivity in Angular. A sketch. Nobody knows what it will look in the end, but this is how I experimented with this whole thing. Without changing the Angular source code, of course. Let's compare them. So we had like change detection on everything. With a pipe, just an experiment, we have now change detection on component level. And with the let directive, we could have change detection on the binding level. In the future, if you would look on the real implementation, it's completely different than what I did, because if you imagine, if you call a signal in an effect, that's it. And if you just wrap your template with an effect, this would be more or less everything that you need to do to implement. So a little bit different than my experiments, but we see how fine-grained change detection could look like, how we can measure it, what benefit it would bring. And the right side here especially is beautiful, because you don't even care about the rest of your component. You just look on one single binding. I have 1 minute and 15 seconds left, but just one slide. So what should I do? Maybe fill it up with random jokes? No, let's do the recap, and I would say that that's it. I showed you how signals work under the hood, not fully in detail, but I guess good enough that you are not scared about the magic. You somehow know what is happening and why. That's the good part, I guess, getting trust into a new technology. I opened up this code, I showed up all the building blocks of the signal package. We had a signal, a computed, and an effect. I talked about change detection, how it worked before, how it could work in the future when this RFC finally lands. I have sleepless nights. Every day I wait until this RFC finally lands. And I showed you how to use it in a fun experiment with a push pipe or with a let directive. And with that, I have to say, start our project, of course, and have a nice rest of the day. It was most probably the coolest conference I ever had from the lineup, and I hope you too. Good evening.